wonder if I should remove my introductory slides at some point. Just for the record, yes, this is terribly typeset, right? I've had this happen to me twice recently, so I just thought I would leave it here intentionally. If you are in any way involved at all in typesetting software or layout, my laptop, that's the whole presentation. All right, we're done. Okay. Thank you. Anyhow, if you're at all involved in any sort of typesetting or search or anything, please consider that ++ is a single thing. I just want to throw that out there. All right, so yes, my name is Jason Turner. I do have my introductory slides here. Since a lot of you have seen my talks or something, you probably know that I have a YouTube channel. I've been releasing a video every single week for over 440 weeks straight now, which is insane. I don't know why I keep doing it. I've also written a few books if you're interested in those things. I try to do development. I have open source projects and some best practices, conversation repositories, and that kind of thing as well. And I've been a Microsoft MVP since 2015, so I am on my 10th year now. I do training as well, and you can have me on site at your company. I like to travel and do training, and I love the Netherlands. And one of the reasons I ended up here is because when I last spoke at the Dutch C++ meetup in Amsterdam, I said, I love the Netherlands. If anyone wants to have me back, please have me back. And the conference organizers emailed me and asked if I was serious about that, and here we are. And also, I just want to point out that a lot of these conferences offer workshops, including this conference, right? So if you didn't know about the workshops that were here, sign up for workshops at conferences. It's a great thing to do. Move to the front. No, that's not very useful right now. I was asked to hold questions until the end, but who's seen one of my talks before? All right, just interrupt me and ask questions. It'll be fine. I will repeat the questions so that they're good for their video. Approximately what my training looks like, just for the record. Okay. So I want to acknowledge, for the sake of this talk, that I am borrowing heavily from other people. The curiously recurring pattern of coupled types from Adi and Bjorn. Bjorn is here. Bjorn is here. Bjorn is there. Thank you. This is, if you want more information on some of the stuff that I'm talking about, that is a good video to go watch. I don't know if it's your favorite version of this talk. I think you gave 2 different versions with Adi, maybe? I don't know which version that is. I know you don't know which version that is. But it's one of them. Hanna Duzakova's use of Ford declaring functions to perform operations without actually defining the function. You'll see what I mean in a minute, but I stole this from Hanna directly, and it's a technique I never would have considered myself. And then Ben Dean likes the idea of trailing return types to basically let your declaration read like a sentence. If I have some operation that I perform on these inputs, then I get this output, all right? That's going to be important here in a moment as well. Who prefers trailing return types? Who thinks they're abhorrent? Who is indifferent? Who chooses depending on the particular function that they happen to be writing at the moment? Yeah, don't do that. Be consistent. That's the worst option. Okay. I want this talk to be even more interactive than usual, so we'll see how this goes. It's going to be a large part driven by you. Again, we'll see how that goes. I hope it works out. It'll be fine. It's one of the advantages that you have when you're asked to keynote speak at a conference is you can do pretty much whatever you want to do, as long as you're not obscene, right? And if they invite you back later, then you know that it was okay. So Stronger typing, just for the record, is not my idea. This is, so many other people have done so much more work on this than I have. So Andreas Fertig's blog, this is the most recent article I have up here. Fluent C++, Jonathan Bocara, Jonathan Mueller, who is somewhere in this room, presumably, unless he's skipping out on my talk. He's over there. Okay. As articles and his own type-safe library. Arna, is Arna here? No, okay. Arna has his own strong typing library as well. And Bjorn, again, and I forget who CSB6 is. Does anyone know CSB6? No, okay. So there's lots of these strong typing libraries out there. This is a code review exercise that I often do with students when I am talking about C++ best practices. This code compiles without warning, and as far as I know, there is no tooling, there is no compiler warning, there is no static analysis that can give you any warning whatsoever on this code. Just stare at it for a minute and let it sink in. Looks good? Some of you are doing this. That's only 2/3 of the problem. This is good. Just for the record, I'm intentionally letting you talk to each other. This is exactly what I wanted right here. The parameters are swapped, yes? This is what else can you do wrong in this piece of code? Yeah. So you see the quote obvious problem that I've got presumably the pattern match and the path reversed, right? But then the third problem, which I think most of you caught at least after I said that there's a third problem, is the implicit conversion from path to string. Okay, so what do we have? We have implicit single parameter constructors from character literals, const character pointer, to path and to string. And then we have a conversion operator from path to the underlying string type, which is why this compiles. None of those things are explicit. And if I can take a moment to just rant a little bit about the standard library here. Who's been programming in C++ long enough that you've read like Scott Meyer's Effective C++ kind of books, right? Okay. I think that's basically everyone, right? Like, those books were written in what? Mid-90s? 92 is the first one, according to Guy. How long has it been considered a best practice to mark single parameter constructors explicit? Since 1989, but let's say, like, how long has someone actually written this down? Since the mid-90s, at least, right? The standard keeps adding more and more types that have implicit conversions. I can't figure out why this is a thing. And I know there's a bunch of you on the committee in here, and I just want you to consider that next time you're working on the library. So this thing compiles because the standard allows it to. All right. How much time do you spend debugging? Is it less than 25% of your time? That's just because you don't test your code. No, I'm just kidding. No, it's a joke. You'll see where I'm going with this in a minute, of course. Would you say 25 to 50% of your time? On a good day. On a good day. What's a bad day? Okay. So 50 to 75% of your time? Okay. More than 75% of your time, like in the debugger, or worse, adding printf statements? Is there anyone who you would put yourself in this more than 75%? Like, you can be honest, it's fine, we're all friends. You're not being recorded, I'm being recorded, right? It depends. Okay.
How do you debug const eval?
Sorry, what?
How do you debug const eval?
How do you debug const eval? Yes. Yeah, I had this conversation with my students because I did a const expert workshop yesterday, and it's obvious. You just attach to GCC. I'm kidding. Right. Yeah. Debugging const eval is its own problem. So come to Inbal's talk, closing keynote, right? Premise for my talk is that I had students in an organization, they kept asking questions about the debuggability of certain features of the language. They'd be like, well, if we use those structured bindings, what does that look like in the debugger? Or if we use a ranged for loop, what does that look like in the debugger? If we use whatever. And I started to I got concerned. Because I've never had students ask this many questions about the debuggability of language features before. I asked, why are you spending so much time in the debugger? They tell me that they have a very high percentage of developer time. More than 50% of all of their developer time is spent debugging issues such as player 1's input was being routed to player 2's position. Game development. So, I mean, just imagine your code might look something like this. You can, again, just let it sink in for a minute. It's fine. This was not taken from them, by the way. This is fabricated, but it's easy to believe that this kind of thing could happen by the time you do some copy and pasting of code. And I know there are game developers in this room, and you've probably seen mistakes like this. Yeah, okay. I won't necessarily name names for the sake of the record. Okay, great. Guy says he's seen this lots at the company. No, okay. So you see right? There's just things just swapped all over the place. This is annoying. So I know that none of you have written code like this, right? Maybe some of your coworkers have. Are you saying your coworkers have? You have.
On the last slide, how many were there?
Oh, how many bugs were there?
Yeah.
Oh, I don't know. I never counted. There's 1, 2, 3. I thought there was at least 4. Yeah, because down at the bottom, no? Update player, input 1 plus player. Oh, I don't know. There's some number of bugs. There's plenty. Okay, so I tell them, you need stronger typing. And they say, that means we would need types for player 1 position, player 2 position, player 1 velocity, player 2 velocity. And I'm like, yeah. If it saves 50% of your developer time, is it not worth the investment? I mean, if you could save half of your developer's time, would it seem worth the investment to do stronger typing? I think it should. Developers are expensive. You're all expensive. All right. So here is, a possibility. This is slideware kind of things. I've got get input, I pass in the controller, it gives me back, whatever its inputs are. It's X and Y kind of thing. And I've got get player 1 position, get player 2 position. I can update the positions, passing player 1 to player 2 position. With some copy-paste related bugs are still possible here. I could, it depends on how far down down this road do I want to go. Do I want a get input for controller 1 and have that return back a strongly typed controller 1 coordinates or not? I don't know. Like these are questions that you'll have to ask. But this starts to reduce the set of problems. Stronger possibility, player 1 input, player 2 input, player 1 position, player 2 position, update position. And then now I can define this thing in such a way that I can only add player 1 position plus player 1 input to get a new set of coordinates that I can pass to this update position or something like that. Now, the worst in this case that I might do is call update position twice, both for player 1 and never update player 2 at all, right? So I'm starting to reduce the set of possible bugs that I might have in my code. So does this work? Is this a way of getting stronger typing? No. No, we don't have strong alias. We don't have strong type defs in C++. There's no language feature for this. This is exactly equivalent of having done the type def here. Just for the record, depending on how old your code base is, if you do have type defs everywhere, you should update them to using declarations because they are much more readable in many situations. And there's even a cling tidy modernize change that does that for you, although it occasionally breaks code. It used to. Maybe it doesn't today. Has anyone used that recently? Modernize? Yeah, did it work well?
Always.
It always worked. Okay. The last time I was involved in using it was when we were transitioning our code base to C++ 11, so I'm old. Okay. So we can do something like this. We might have player 1 position, has a float, 2 floats, player 1 input, has a couple of floats, and then I'm going to declare my own plus operator, so position plus input gives me back a new position. Copy and paste this for player 2. But it's a start. Comments? Yeah?
What if we sometime get player 3? Do we multiply over and over again?
Yeah, so if you have player 3, then do I have to copy and paste all of this again? Yeah, obviously we want to avoid that kind of thing. So a solution for this is to do tagging. So I can say I've got some sort of position and input thing, and then I can do this using declaration to say player 1 position is the position, and then I'm just forward declaring a struct there. It doesn't matter, I don't use the struct, I just need a unique type name, and so then I might say struct player 1, something like that. And now I could still have a copy paste bug where I might say player 2 position equals position of struct player 1 again, and I'm going to end up with the identical types. I want to avoid doing that, of course. But I don't know of any tools or anything to stop us from doing that right now. But that's the basic idea for how we can start to get stronger type defs in C++. Now, who has actually worked with a strong type def kind of library before? All right, a fair number of you. It can be a little bit of boilerplatey, like how do I decide what operations are going to exist for this kind of thing? And so this talk is partially meant to be inspiration of how can I write stronger typed code so I have fewer of these bugs, but also I'm going to show some techniques that I just found while messing around one day. And hopefully you'll find them interesting. All right. Your turn. I want you to spend the next 5 minutes talking to the people around you and coming up with your own situations where stronger type defs would have saved you some serious bugs in your code. And I'm going to make notes when you give me ideas. So. It is kind of loud in here, isn't it? I'm just listening.
I was just saying, stronger types are great for it's ideal for the fundamental download types, which is used everywhere. Ultimately, everything boils down to its floats, balls. Sometimes you just need more another abstraction there on top of that. So it's not a ball. It's are we going up or down? In or out?
Yeah.
It's stronger types provide a sufficiently small layer of abstraction to assist the user. To incur or a compartment.
I burned 7 years of my work on stronger types. Units.
We'll see if you like. We'll see if you like what I. Just listening. What? What did you say?
Oh, this is really good for the video.
Yeah, I know.
Thank you for shouting out all the community people like.
So I find it funny that I was at PyCon in the Netherlands yesterday, and they were all talking about how type annotation is so good.
Yeah.
They've got a stronger type language, but you should best practice. You should have type annotation.
All right. Let's go ahead and start winding down the group conversation. Although this really makes it much easier for me if this is the next 30 minutes, then I don't have to do anything, right? Then I can just... That was a great keynote. I don't know what he said. We all talked to each other. I bent the microphone slightly to get out of my way. Are we good on audio still? All right, sorry about that. I was trying to make sure that the private conversations weren't recorded too much on the video. You might need to edit some of it. Okay. Okay, what did you come up with? Does anyone have an example that they would like to share that actually you thought of immediately or something? Units? Yes, we have someone who cares very much about units here. Is that what you were going to?
Function parameters.
Just in general, function parameters.
You've got 6 bools in a function parameter. It's the wrong function in the signature for start.
Yes.
6 bools.
That's if you didn't hear that, if you have 6 bools as function parameters, it's obvious what the code is doing, right? Now, if you have more than 1 bools, then it becomes too many. Did you have something you would like to?
Interfacing with the libc, everything is int. When you network parameters and stuff.
So interfacing with C library APIs where you just simply don't have an opportunity for stronger typing, that's an interesting one. So who does do things like write lightweight wrappers around POSIX calls and whatever to... It's a fascinating weighting. This side of the room is more likely to use stronger typed things than that side of the room. I taught a class once. Who all is a new C++ programmer? Literally everyone on this side of the room raised their hands. I'm like, well, who's been, whatever. And everyone on this side of the room was more experienced. They had Yes, they had partitioned to themselves, and I was teaching 2 classes at once, a bunch of newbies and a bunch of experienced people. It was fairly early on in my training career as well, so it was, well, you never know what's going to happen when you do these things. Okay, so POSIX, CAPI, that kind of thing. All right. Anything else? Yeah.
Enumerations.
Just enumerations, like in general.
You have enumerators, but someone violates and puts a value into
Yeah.
that is not enumerated.
Ooh. You know what? The stuff I've been working on, sorry, I should repeat that. It was pretty good. If you have an enumeration and someone puts a value into it that's not an actual named value in your enumeration, then yes, you can have problems there. And the stuff I've been playing with, I actually do have a solution for that, but I don't know if we'll have time, but you can, there's a QR code up in a minute, and you can look at what some of the other options in there. Yeah, and just for the record, enumerations are interesting because even with enum class, or as I prefer to use, enum struct, it's an interesting conversation to have. They're both exactly equivalent and valid. Are the members of an enum public?
Yes.
Yes. So arguably, enum struct makes more logical sense. I had actually a student point this out to me, and I'm like, you know what, you're right. I've been using enum struct since then. So you can put any value in an enumeration that is representable by the underlying type. There's different rules depending on whether or not it is a scoped enumeration or not, but there's nothing in the language stopping you from doing this. So you hit undefined behavior if you go outside the underlying type number of bits thing, and we've played with some of those things. All right, anyone else like to share some? Yeah, go ahead.
Yeah, longitude and latitude.
What's that?
Longitude and latitude.
Longitude and latitude. How do you currently represent longitude and latitude, or what is the good underlying type for those?
Double.
What's that?
So we have both a double.
Yeah.
Also in integer, if you just take the entire scope and you put it like the entire integer is 380.
So you can use an integer or a double, you're saying?
Yeah.
Okay. Yeah, okay, all right. Does it make any logical sense at all to add a longitude with a latitude?
Not as far as I know, but it happens.
But it happens.
There often refers to latitude, longitude.
Yeah.
You have also longitude, latitude. Both conventions exist, and therefore constructors really need to know which one goes first.
Okay, yes, so the argument here is sometimes people write their APIs with longitude first and latitude second, and sometimes with latitude first and longitude second. In all seriousness, would it make sense to say, if I added a longitude plus a latitude, I now get back a coordinate? Like I get back a new type. Does that make any sense or not? No? Okay. I mean, people do things. I don't know. As long as it's strongly typed, we can overload operators to do whatever we want to in this language. Comma operator overload. Latitude, comma, no. Don't do that. Okay, anything else? Oh, well, goodness gracious. Yeah, Peter, I think your hand went up first.
The typical thing where we have in C-compatible code, or really old C++ code bases,
Yeah.
we used to have a definition for false being a 0 with a cast of bool in front of it.
Okay,
That's implicitly convertible to floats, ints, pointers,
okay.
almost everything.
So a 0 cast to a bool becomes meaningless.
And if everybody says false, you can pass it to almost everything. The the moment you change that to an actual false, you find all the places where people did.
Right. So Booleans with CAPI interaction that aren't using Booleans. They're using integers to represent Booleans, and then everything goes to heck.
Indexing.
Indexing.
You could
Ooh.
vector adapter that only accepts indexes the right type.
Vector adapter. So indexing. So if I index, well, I mean, like size T is basically used everywhere in C and C++ for indexing. That's fun. All right, all right. All right, so we've got some bools, we've got some indexing, we've got latitude and longitude. Oh, I wrote down int/double instead of lat versus long. Well, that's silly. Yeah. Well, I mean, to be fair, the standard isn't very strongly typed when it comes with things like passing an integer to a, double. I hate that, really do. We need W conversion should be enabled by default. W conversion with errors. Actually, that's a fun question. Who has actually enabled W conversion on your project? Okay. Again, it's weighted to the right side of the room. So I guess, I don't know if it's the people who came in later are less likely to use stronger types. When you enable W conversion, let's just give me a ballpark. How many months of effort did it take to get the code to compile? 10 months? You're serious? Okay. This is, it's not a joke. If you have a highly numerical system and you have not enabled W conversion, you're going to be very sad.
You're making the assumption we're done.
Making the assumption we're done. 2 years on a game engine to enable W conversion, and you found bugs in the process. I think everyone heard that answer. And you mentioned some of that stuff in your book, I think, too. Yeah. So Guy has written a book called Beautiful C++. You should check it out. I got the title right? Yes. Along with Kate Gregory. Guy is here if you have your copy and you'd like him to sign it. All right. You see the QR code. We're going to see how this goes. Part of the problem is that I recently dropped my laptop and my touchpad doesn't work like it used to. And that is very bright, right? So let me put this back in dark mode and you can tell me which one you prefer. It's too early for light mode? Is that okay? Yeah, those of you in the corners in the back, is this okay? I can embiggen it a little bit if... embiggen, perfectly cromulent word. You gotta love The Simpsons. Okay, so this is a demo of my strongly typed library. I've got seconds with my strong alias, my strong type. I've got velocity. I've got distance defined here. This is just a starter. And on line 158, you can see there's a fair bit of code that is hidden here because the entire implementation of this library is up here. And just for the record, I'm not trying to sell you on my library. If people use open source work that I've done, that means I have to support users for free. And I used to want users for my open source libraries. I don't know. So on line 158, I am telling my tool that if you multiply seconds by velocity, I want a distance back. Okay? And those lines, 154 through 158, are all that is necessary to make the code on line 66 compile. I say, if I multiply a seconds by a velocity, then I should get back a distance. And it works. It's like magic. I don't know of anything else that's quite this easy. If I didn't have the multiply there, then the code will fail to compile for two reasons. You can see the squiggles under the star V, and you can see the squiggle under the result there. So everything fails. I can't multiply these things together, and I don't get the right type back. Are you familiar with this little tool I'm using right now, by the way? Is it? If you're not familiar with Compiler Explorer, you really need to become familiar with Compiler Explorer. It is incredibly helpful for this kind of thing. And we have one of the core maintainers of Compiler Explorer here today as well. Just so you know. I like calling people out. That's what I do. Okay, so which one of the, oh, sorry. Right, multiply is a function but not an operator. That's not the same thing. Yeah, I'll show you what this code is actually doing under the hood in just a moment. I wanted to, see, I'm terrible. I think I'm supposed to stand on that thing when I'm talking. I break the rules. I've considered giving a talk where I literally intentionally break all of the rules, like pointing at the screen like you're not supposed to do. But you are all here in the room with me, and I want to make sure that you have a good, enjoyable experience here. Okay, let's see. If I wanted to do something very simple, like if I wanted to, well, give me a good, strongly typed Boolean thing, a name of something that would be a strongly typed Boolean. Did you say is annoying? Okay. Nope. So that's just going to be a strong alias around a bool. And so I think with any of these, I've had people point out like, oh, well, if you used the decal type of a lambda, then you know that that would be a strong type at that location because they all have to have their own types. But then it breaks across compilation units, translation units. We don't want to do that. No. Okay, so if I've got my strong alias for a Boolean, then I can easily write a function. What should this function name be that takes a parameter about whether or not something is annoying? Or is it a return type?
Query box.
A query, all right, neighbor. All right. So, I mean, it could be that simple for just returning returning a strongly typed thing. This is not going to be implicitly convertible to or from bool, but those are things that we could potentially enable. Does it make sense to add or multiply or divide this thing by something else? No, I don't think so. All right, let's do. What's that? Annoying multiplied by a scalar gives me back a very annoying. I don't know. So I'm going to do the copy and paste to save typing, even though I really hate doing the copy paste thing here. If I've got a latitude, that is a double. So this is where you can definitely get yourself in trouble. Like no matter how hard you try, right? You do have to pay attention. Ooh. Don't do that. Now, you reach the point in the talk where you're wondering, did I spell that word right? What's that? Oh, did I leave out a letter? No. L-O, wait, what? What are you telling me to do? The first three letters. Oh, lawn. L-O-N. Oh, okay, yeah. I could have done that. All right. So now these things are not addable, right? But I can just say, okay, if I want to make sure that a longitude can be added, or a latitude can be added to a latitude, then I can say lat plus lat equals. The comment was, is annoying. That won't actually work with my current code. So I can say these two things can be addable, and I'm going to get back at a latitude, right? So again, I do recommend watching Bjorn's talk on these curiously recurring, strongly, what the heck was it called? Coupled types. The coupled types. And this is the kind of thing that like really works well for like physics or for game engines or whatever. Like things like seconds times velocity, equals distance. Distance plus distance is a new distance. And then you do have questions, and we'll look at one of these in a moment. Like should, by default, I don't have these things as that word that I for some reason can never pronounce. Commutative. You can't, by default, if I said, like I have up here, multiply seconds times velocity, if you try to multiply velocity times seconds, that will fail to compile. You have to enable that separately. Okay, let's see where I am in my code. No, there we go. So the question was, can I redeem this? That is not a useful thing to click on.
I think there was a question over here.
Oh, I'm sorry, yes.
Now, what can you do with is annoying? So you can assign a true or false to it?
You can construct it from a true or false, and you cannot assign a true or false from it by default from what I currently have in this. Like I said, this is meant to be partially inspiration. Don't consider this to be a complete library, and I'm not trying to get you to use it, right? This is just a discussion about the possibilities. And so I want to, I'm going to run out of time here in a minute. We'll get to the implementation now here. But that's the basic idea. And I can redeem this. I can make a strong alias for a file system path to say my path. I can make a strong alias for a path and for a file name, and then say file name divided by path gives me a new file name, right? Because if you use standard file system path, you're used to using the divides operator for appending paths. So then I could say, well, path divided by a path gives me a new path, or directory, sorry. Directory divided by a directory gives me a new directory. Directory divided by a file name gives me a new file name, right? These are all things that you can do, keep things as strongly typed as possible. But we will move on a little bit, and we'll discuss what I'm actually doing here. Yes? And the multiply, that kind of thing, do you have to declare that in the header file? Yeah, yes, you would want to put that right after you've declared your types, probably. You put it in a source file. Again, this is not really a tested library, okay? It's an idea, and I just want you to be inspired by some of these ideas. So this is my vector implementation, just for the record. I did declare my own operators for my vector implementation. So a vector of an x and y multiplied by a float gives me back a new vector. Right, vector plus a vector gives me back a new vector. This is, I think, for those of you who work with coordinate system kind of things, this should look fairly familiar. Okay, so how does this work? And I want to make sure that you have time to get to the next talk. A requires statement basically is a Boolean. It's a compile time executed thing. It is a Boolean, or evaluated thing. It does not execute code. It basically, for the sake of this talk, says, is this code valid? So line 7, if I were to comment that out, this is going to return true, because I can perform a modulus operation on an int and an int. And line 8, if I comment that out, it's going to return false, because I cannot perform the modulus operator on a float in an int. Okay? We've all encountered this. Variable templates, just as an aside, are kind of a handy way of doing stuff like this while avoiding creating function templates. So I can have a variable template. I can say this has modulus is the requires of, it's kind of synthesizing that I have an object of type left-hand side, an object of type right-hand side, and is it a valid question to ask? Am I allowed to perform the modulus operator on these things? And it'll return true or false. So it's just another way of looking at this. Then a concept. Yeah, no, it's. I'm just like building up a couple of ideas here. So concepts, these things are basically built from require statements. They don't execute codes. They're just asking, is this question valid? They actually have other properties that we don't really care about. The variable template example, I could use it for the sake of this. Like, it doesn't matter. Requires clause can take basically any Boolean expression that's a constant expression. All right, so kind of like a variable template, I just kind of built this up. If you've never seen concepts before, this is the idea. I'm declaring a concept. It is a templated thing, and it asks, there's this thing, I worded that, modulable. That's a word, right? Well, do you have a better word for it? The answer is annoying, just for the record. All right. So with these concepts, I can kind of inject properties by abusing function template lookup, evaluation order kinds of things, and I can create my own concept. I'm saying this thing is operable if a function called operation exists that takes both of those types. And then I've got my constexpr_bool function on line 5 that declares this op function here. It just returns true if these things are operable. So I've got S1 and S2 defined, they're empty, and then on line 12, I'm just declaring a function. I'm not defining the function, I'm not evaluating the function ever, I'm just saying, yes, there is an operation called operation that takes the type of S1 and S2 and it returns void. My battery is now fully charged. Thank you, laptop. So this returns true because there is a function called operation that takes those two types. If I comment this out, then this code returns false. So I've just told the compiler, it's okay, you're allowed to do that operation. And it's like, you know what? I think I'll let you do that operation. All I'm doing is forward declaring a function. And this is where I said I stole from Ben heavily with the some operation that takes an object of type 1, takes an object of type 2, and returns a new object. So if we put it together, this is closer to what the code actually looks like. Then I've got a concept called addable on line 4. I've got my plus operator overload that I am now declaring. That's part of my little library. And I say this add operator is enabled using the require statement if these two things are addable. They're addable if a function called add exists that takes those two types. So then on line 8, I return the decal type. So what is the result of returning this operation? Remember, I don't have to declare this operation at all. I'm saying, what should the return type of this operation be? And then I construct a new object with that braced initialization on line 8 and say, I'm going to construct it with the result of adding those two underlying values together. So from the user perspective, you just need lines 11, 12, and 13. I have S1, S2, S3. They contain ints and floats and doubles. And then I declare, if I add an S1 plus an S2, then I want you to construct an object of type S3 on line 15. And so then the compiler says, OK, on line 18, the user is attempting to add an object of type S1 plus S2. Is there a plus operator overload? Yes, there is. Is it allowed? I have to ask if it's addable. Is it addable? Does there exist an add function? Oh, look, the user forward declared an add function. Well, if they want to do this, what return type do they want it to have? Oh, they want it to have the decal type of this declaration. So this becomes S3 initialized with the result of adding the two underlying values. Yeah? Is that neat? It's neat. Okay, cool. How do I keep it organized? I've already told you I haven't tested this library. I'm not trying to sell you on a product. I want you to be inspired and think about techniques you might use in your code, okay? Or things that you might do, yeah?
Why do you need the remove CV ref?
That might have been vestigial from when I was testing this code, but you do often find when you're doing this stuff that you're like, the thing was deduced as a const reference. I just want the underlying type. That's probably vestigial here. Yeah. Yeah, okay. So then we already covered why the tag type is necessary. This is basically what my strong type def type thingy looks like. It's super simple. Yes, Jonathan?
You can actually call the tag just the name of the type def.
I can call the tag the name of the type def. I can say struct my int.
Yes.
When I tried that, it yelled at me. Other people are saying that it should be allowed. Maybe I did something wrong. Okay, so, well, this code currently compiles. This is not just slideware. And so you're saying if I did my int right here, yeah, conflicting types. What? Yes, I know, but that's what he told me to do. No, okay, that definitely doesn't work. Yes?
Actually, you can do two improvements here, because instead of using alias, you can use strong type, because people not want to see your strong type defs or aliases in the error messages. They want to see my int in the error messages. Having a strong type will improve the user experience.
Okay.
And also with this, if you put strong struct my int,
Yes?
derived from strong type def, with CRTP, you can put my int as well.
Wait.
My int in line 6, in the beginning. Struct my int, right. Instead of using. Do a strong type, right. Then colon instead of equals. And then use my int as a tag type. CRTP.
And then use my int as a tag type
CRTP.
here.
Yes. And curlies. Curlies before semicolon.
Yeah. Curlies.
But the error messages, and you reuse the tag.
Yeah, see, like I said, I'm a newbie at this whole strong type thing. Yeah. That is definitely cleaner. Okay, I've got 4 minutes. We're moving forward. All right, so, well, I mean, no, hey, that's the last slide. And it's still terribly typeset. But yes, this will give you enough time to get to your next talk, which starts sharply at 11. But this is who I am. Subscribe to my YouTube channel if you haven't already. And if you are interested in contacting me for any training or whatever, like I said, I love coming to the Netherlands and also Germany and Poland and, whatever. I have countries. I might give you a new country discount if I have not yet done training in your country. So talk to me. Thank you, everyone.